creating. So today we'll start with Python, basic syntax of Python and all the data structures and variables within we'll look into, and then we will visit object-oriented programming. I'll give a brief intro on classes, and then tomorrow we'll discuss about object-oriented programming. So first thing, I'll just form this repository. So you will know the GitHub desktop application. You need to install this in VS Code. All this you need to install, and then you will need to install Python, python.org. If you go here, you can download the binary for your respective operating system, and then you can follow the instructions. So I have Python installed already, so I'll start with owning this repository. So I've cloned this repository. Let me, here it doesn't have. Using there, you can clone this, open GitHub desktop. This is my GitHub desktop application. I'm going to clone this repository. I'll use this as a basis for all my Python code. So I can open Visual Studio from here. Here I'm going to initialize a Python environment. So I'm opening terminal. If you go to terminal, new terminal, it'll open, and there is a shortcut for that. You can do Control-Shift backcode. I'm going to use that. Now, if I type in Python, I can enter into the Python shell. If I want to come out of this Python shell, I can do Control-C and enter. So there is a package manager for Python called pip. So I can install packages with pip install, Jupyter. Let's say this is a utility for working with Python files. Let's install Jupyter. This is the path variable is not updated with this location. Let me add that. So it's installed, but in order to execute Jupyter scripts, I need to add these paths into our system environment path. Let me share control panel. basics. So when I enter Python, it goes into the Python shell. First thing that we need to look at is how to do a print. Let's do world. If you see this, this is called read evaluate print loop, REPL. So whenever I enter a Python statement, it will execute immediately. So compared to C and other languages, Python is an interpreted language, whereas C and Java all are compiled languages. So right now in Python, as soon as you write code and enter, it will interpret and execute that particular statement instead of compiling into a binary code. So it's faster to prototype, but performance-wise, it's a little lacking compared to the compiled languages. So first thing I'm going to look at is, this is one way to execute Python code. So let's say I want to execute Python code through a file. So I'm going to create a new file. Hello. Fine. So in files, the extensions specify which data this particular file will contain. So py extension is used for Python code. This data I'm going to do level from hello.py. So this one I can execute through the Python interpreter by issuing Python. The same as this read evaluate print loop, but except that all our statements are put under one file. So this is statements. There are things called functions. So this is a basic unit of Python. I'll go into how to define a function and all that. I'll just give you a quick glance of function. This is a function. Print the same statement. If I want to execute inside a function, I'll just move this to inside a function. So note here that I'm indenting code within this function. So Python doesn't have semicolons as the ending statements for an ending character for statements. So Python interpreter interprets code based on the indentation level. If I indent one part of the code inside a definition, it means this is a kind of a block. We are creating a block of code. In other languages, if you see C language, so we create blocks in this CR, we create opening bracket and closing bracket. So in Python, we use indentation for doing the same thing. So we are actually creating a block. So I want to add one more statement here. This is another line. All this will be under the same indentation level. This is out of the function block. So this statement is not part of the function. Let's say I want to execute the function. This is a function. How do I call that? It's through like this. So this function gets executed, which prints these two lines, and then this prints this line. If I put this line after this, first this statement gets executed and this gets printed, and these two lines get printed. Let's do it. This is how the function worked. This one got executed first, and this function got called and got executed. So that's a small glimpse into what functions are. We'll go into functions and classes and methods. Functions, methods, what's the difference between class, function, and a method. So let's go to our Python interpreter. Let's execute PWA print loop. So in computer science, if you say X is a variable, so I'm giving the value 5 to this variable. How does computer store this value? Is through memory addresses. So this particular X variable will have a specific address assigned by the interpreter or by the CPU, which will have the value 5 in it. And if I have same thing here, X is now having a specific address. Addresses will be based on the memory architecture. You will have a number assigned to it. And the value of that address, the value that is placed in that memory address is 5. If I do print X, this is going, CPU is going to access that particular location of X, the address, and reads out that value in that address and prints it out. That's the basic functionality of variables. So these variables can be different types. Right now I've stored it as a number. X can be a string or a number. It's a dynamic language. Python is a dynamic language. It doesn't require us to define the data type while declaring the variable. You can assign the value and it will automatically determine the variable type, value type. So let's say I'm going to assign a string. The strings are defined in Python as like this. They use double quotes or single quotes. This is same as double quotes. So now if I do print name, it is a string. If I want to know what's the type of this variable, I can print it with the type of name. It is a string. So if I do type of, so now we know what's type of the value that we are storing based on the variable that we have, based on the value that is assigned to it. We have the type dynamically found out by the Python interpreter. So the name variable is assigned with string and X is assigned the type integer. And we also have, so what about the numbers which are decimal values? Let's say take example of 1.5. So I'll just print the type of 1.5. It's a float. It's a floating point number. So why do we call that a floating point number? Is because let's say I have 1, 2, 3, 4, 5, 6, 7. This is one way. Let's say 1, 2, 3, 4, 5, 6, 7. Dot 7. So this dot is actually floating. The computer does not understand where this dot is. It interprets the numbers and then the position of the decimal point. So the decimal point is actually floating. That's why we are calling it as a float instead of a decimal. So similar to this, if we had a background of math, we have like complex numbers. Let's say square root of -1 is a complex number called I. So in computer terms, it is called J. So if I just print 1J, it is 1J. So if I print type of 1J, it's a complex number. This is also one of the data types. But most of the times we won't be using this data type in our day-to-day work. So I can do complex number operations also here. I just try to print multiply 1j with 1j, which is going to be -1. It displays -1 plus 0. So this is a complex number. -1 is the real part of it, and this is the imaginary part of it. So this is how we do complex math. But this is all we won't be using most of times. How a detailed program work. Similar to this, we have strings. Let's say string 1. I'm defining string 1, and I can do operations on string 1. I will append string 1 with string 2. These are two strings. So I'm just summing these two. We'll see what happens. So it's actually appending or concatenating these two strings. When we do 1 plus 2, it does sum. When we do string plus string, it does concat. So this is dynamically determined by the interpreter what to do with this operator. This is called the operator. So we have data types. We have seen integer data types, float data types, complex numbers, and strings. Now let's see booleans. So booleans is true or false. Let's say this is true, and Python has true and false. These are the two different boolean data types. So if I just try to print true, it doesn't. True does not exist in Python. The actual boolean for true is capital T, true. Boolean for false is capital F, false. But one thing we can do, true is actually a variable name. So just like X or A or some I name, define true as a variable name that has true as the value. What will be the type of true? It's a boolean, because I've assigned value true to the variable true. So this is kind of confusing, but don't worry. So just use true, capital F, false for all your programming in Python. Let's now visit different types we have seen. Now, how do I deduce booleans? So if I do compare two variable values, 1 equal to 1. So this is actually a new thing. If I say A equal to 1, this is an assignment, whereas I do 2 equal to signs, it is a comparison. 1 equal to 2, this is a false. This is how we compare two values. And then this is basic data types. In Python, there are complex data types also. Let's say in C and other languages, we have arrays. Instead of arrays, we have lists in Python. Two Boolean data types called true and false in Python. So how do I deduce a comparison versus assignment? Yes, let's say A equal to 1 if I do. It assigns value 1 to variable A. Let's say if I do A equal to 1, this is a comparison operation. This is a true statement, which means it's actually getting the value of A and comparing whether it is equal to the value 1 or not, whether the statement is true or not. I'm asking the interpreter, is A equal to 1? Here I'm actually assigning 1 to variable A. And similarly, if A equal to 2, I'm asking whether A's value is equal to 2 or not. So that has to give me a false as a written value. That is what it is. Because I've already assigned value 1 to it. So if I assign a equals 2 now, and if I do the a double equals 2, it says true. This is comparison, this is assignment. Okay. So now we have seen the basic data types of Python. There are complex data types called arrays and dictionaries. Arrays, we call it in C language, but in Python, it's a different name. So these are called list items. Let's say I'll define a list. That list is going to contain 1, 2, 3. It's a list of items. If I do type of my list, this is actually a list. So this list can contain nested lists also. My list actually can contain one number, one string, one boolean, one float. This is all valid. But in C, arrays do not allow having different data types. This is allowed. If I do print my list, it will print actual values. And similar to this, we can have nested arrays, nested lists. I have one list. Inside that, I will have one more list. 1, 3, 4, 1 more list called 5, 6. Or I'll have one more list with strings in it. This is all valid. This is all valid. If I print my list, it has a list has a specific property called length. You can find the length of a list by length operator here. The length of this my list is 4 because it has 1, 2, 3, and 4 elements. This doesn't count the nested lists. So as long as my list is concerned, it only has 4 elements. Those 4 elements can be lists, underlying lists, or it can be dictionaries or any other data type. So that's about list length. So this is one type of complex data structure. There are something called sets. So whereas list is a this is a list. Try to print the list. This shows all elements. There is something called set. My set. Sets are defined like this. 1, 2, 3, 4, 5. I'll set again 1, 1, 1, 3, 3. Let's do print my set. Let's see what's the difference. It's only printing 1, 2, 3, 4, 5. It's only printing unique values. So in a list, we can store duplicate values, whereas in a set, we cannot store duplicate values. A set is a unique set of values. Let's try setting, try a set having multiple data types. Print my set. It's only storing unique values. So that's about sets. Let's try getting the length of a set. I'm going to define a set 1, 2, 3, 4, 5, 3. It's 5. let's see comparisons. Let's do comparison on both lists and sets. There is a list called 1, 2. I'm going to compare if this is equal to 1, 2. If this is true, what if I change the order? Fonts, lists or order specific. So if the order changes, they both will not equal each other. Let's see how about sets 1, 2. Also have one more element 3. I'll set 1, 2, 3. This is 1. Lists and sets do not differ in this. Let's say 3, 2, 1. Enter. This is also true. So order does not matter in a set. Order matters in comparing a list. Similar to lists, we have something called tuples. A tuple is generally defined like this. Similar to lists, 1, 2, 3, but except that it will have this kind of syntax and print A. This is a tuple. Okay, let's come to the definition. What's the difference? I have a list called A, same thing, 1, 2, 3. And I can add one more item to B. Let's say B dot append of 4 if I do, and then print B. It is 1, 2, 3, 4. It has appended fourth element into it. Let's do the same thing with this. Append of not allowed. Basically, a tuple cannot be edited. Once defined, it cannot be edited. That is having tuples. And why that is not editable, or why do we need that uneditable feature, is for optimizations. So when I'm editing a list, the memory optimizations will go for a toss. So whenever we add one more element, it has to relocate the data and store that extra information where the addresses of each of the elements are. If it is split into multiple locations in the memory, it will have to store 2 addresses for this. So it's an internal mechanism how the interpreter converts this code into machine code. So whereas in a tuple, if I define it once and I don't have to store extra information for me to retrieve or manipulate as that tuple. So if I have to make it editable, I will have to make some more metadata stored in the data structure. That extra information is not required for a tuple. That is why it is efficient, memory efficient. So when we have large sets of coordinate information, let's say, especially where we use these tuples is for storing XY coordinates. Let's say 1, 3. So basically, this XY coordinates are usually XYZ coordinates. Both even in 3D programming, we have XYZ both, all 3 coordinates. This is especially very useful in game programming. Not just a game programming. If you want more optimized code, memory efficient code, you can do this. You can use tuples. Similar to this and sets, we have length property for tuple also. Same thing. There's no difference. And now comes the dictionaries. So dictionaries are a little bit more similar to our dictionaries. Dictionaries store words and their meanings. Similar to that, they store keys and values. So let's define a dictionary. So dictionary syntax is like this. It's similar to set syntax, except that we will have keys and values. The keys are always strings. Apple. I'm going to store something like where something with dangerous name. And enter. Let's see length of my dictionary. So there are two elements in the dictionary. Now let's access what is an apple. I'm just looking for this word apple. I'm trying to see what's the meaning of that apple. You can store anything in here, not just strings. You can store any even a list or another dictionary also, a nested dictionary also you can have. So it's just that key and value should be there. The value can be an integer, float, list, dictionary, tuple, or whatever you want to have. So the key should always be a string. Let's see now. Let's access something that is not there in the dictionary. Okay. This key is not defined in any of these keys here. It's not a frozen error because this dictionary does not have an element with the name method. Okay. Now I have the dictionary and I will redefine one more value here. Apple, same key I'm going to use. And I'm going to use something like, sometimes it's green. Green. And let's print what is in my dictionary. Let's access my dictionary. Apple. What is it? It gives the last entity. So when I'm appending a new entry, it is actually replacing that particular key previously defined. Let's say I will define dictionary. It's nothing but saying dictionary of there. I want to do something like here. Some text replaced. Now if I print my dictionary, apple got replaced by this and pear got replaced by this. This is how we manipulate dictionaries. So this is pretty much the data structures in Python. So what we have seen into basic data types like integer, float, string, and then complex structures like list, set, dictionaries, and tuples. And complex data types also is there as a basic data type. Now let's see how to compare two values or two variables, or how to do arithmetic and comparison operations. So let's see arithmetic operations first. So I will define 1 plus 1. This is in general. In every language, this is same. And let's do multiplication. Multiplication is specified by star asterisk. This is how we do multiplication. If I do 2 stars, this is actually raising the power of 5 by 2, which is like 5 square. And 5 to the power of 3, this is how we get it. Double star means it's a power. And let's do a division. By default, the division is going to give you a floating point number because the remainders will not always be zeros. So if I do 20 divided by 6, it gives decimal values also. That's why by default in Python, it is by default is going to return a float, any division. So if I do 20 divided by 6, this is an integer division. it doesn't take care of the decimal values. It only gives what is before the decimal. And if I want to see what's the remainder, let's see 20 modulo operator 6. This is the remainder. So similar to these operations, we can do operations on strings also. Just like we have seen earlier, string 1 plus string 2 gives a concatenated string 5, 2 plus 1. This doesn't give 2, but it actually gives 11 because these two are strings. Similar to this, I will do operations on a string. This is a string. I'm multiplying it by 4. Let's see what happens. It's actually repeating this 4 times. This is a convenient way to print for formats or designs. And if I use 1 plus 4, what happens? Goes added. So string and the number is cannot be added. And now this is about arithmetic operations. Let's see comparison operations. Just like we have seen, 1 equals 1, double equals 1. This is a comparison operation. And 4 less than 5, this is true. 5 less than or equal to 5, this is true. 5 greater than 2, 5 greater than or equal to 2. This is all about basic less than, greater than, equals, greater than, equal to. All this we might have already seen. And there is logical operators called and or, and or and not. So how do I do those? True and true. This is like if you have seen logical operators, you would have already visited logic gates, truth tables, true and true, true and false, false and false, false and true. All these combinations we can use. And true or false is also true. It's the only scenario when or will fail is when there is both are false. If both are false, then it becomes false. When and true will become true, true and false will become false, everything else will become false. False and false becomes false, false and true becomes false. Okay, say I have a sentence. My sentence. This is a statement. Let's say if this will see the syntax and all. I will show you sometime the if conditions and all that. If publish in my sentence, print. This is a statement wrote. And then I have this and if software engineer and my sentence. This is a statement for software engineer. Okay. If publish in my sentence and software engineer in my sentence. This is a statement about publish software. Let's say instead of software engineer, I'm going to use something like test engineer, or let's say locomotive engineer. Is not executing because this is true, but this is not true. So this block of code gets executed only when both these statements are true. So if you consider true, this results in true and this results in false. True and false becomes false. So if condition works only when this condition wholly becomes a true. Try to false. Okay. Okay. See, this is kind of true and true or false will result in true. So if true means it will go inside this loop. Let's see if block. Let's visit the if condition. If true, inside the if. If false, inside if. This doesn't get executed because this is false. So the syntax or logic of if is if something is true, then execute these lines is what this means. If, which is false, if some condition, do something else. This is what if syntax is. If something is true, some condition is true, then execute these lines. Understood? So we have seen and or, true and true. So if true and true, print O, else if true and false, print true and false. This actually does not get executed, this statement, because true and false will always result in false. This if condition or else if condition works only when this statement becomes a true value. And if this thing gets executed, if true and false, this doesn't get executed. Yes, this only is resulting in a false statement. So there is something called not operator, which negates true values. If I do a not on true, it becomes false. If I do not on false, it becomes true. If not true, print. True actually is becoming false. So if condition gets executed only when this entire thing becomes true. If not false, print false. If not false, actually resulting in a true statement. If true means this block will get executed. It can be confusing once we get into coding to see how things work in practical, you'll understand. It's okay. We're just covering the basics. So apart from arithmetic, comparison, and logical operators, we have membership operators. So let's take an example of a list 1, 2, 3, 4, 5. If I want to find out if specific element is there in a list A, I can find out if, or like I can say that 4 in A. This actually checks if element 4, value 4 is there in this list or not. Let's say I will try 10 in A. This returns false because 10 value is not found in this list. Something similar, we can do this membership operator for strings also. Cat in my pet cat. This is true. If I just do cat not in my pet cat, so this checks if cat is not there in this particular string or not. That statement is false because cat is actually there. We are trying to see if it is not there. So that gives false. So this is about membership operators. Now let's look at if-else conditional statements. So we have already seen that. So I'm going to define a value, assign a value true to A. If A, I want to print something. It is true. And I will execute one more statement there. So let me also print this. If A is true, both these statements get executed. And this gets printed. If you see here, this statement gets executed. These two statements get executed only when A is true. If I now change it back, I will change A to false. And same code I'm going to execute one more time. Only this thing gets executed always. If A is false, these two statements did not get executed. This is how if conditions work. Something similar, if I define another condition called else, print it is false. So if A is true, this gets executed. Otherwise, this gets executed. And this gets executed always. That's it. It is false because A is false. We have made A as false. This is getting executed. Let's define one more value. B as 2, A as true. Let's define the same function. I'll just add one more nested if condition here. If B print B is true. And execute now. So it is true. This thing, these two statements, and also this statement got executed because both B and A both are true. So instead of this, I can actually have if A and B print A or B. This is how we use AND. So something similar. We, instead of having nested statements, we can make use of loops also. Let's say I will use a list 1, 2, 3, 4. I want to iterate through all the elements in a loop, all the elements of A in a loop. I can do it with for item. So this is just a value name I'm giving to. I have to use an iterator in. So we have used in as a membership operator. This is a different context. This is part of the for loop syntax. This in is not membership operator in this context. But item in A, print item. So actually lists, dictionaries, and sets, dictionaries, lists, and tuples, all these are called iterables. Iterables means we can actually iterate through each of the elements and do some operation on each of that element. So as long as we have an iterable item, we can use in to loop through all those values in that iterable items. So for item in A, if I'm printing here, it prints all the values. It loops through each of these items and prints them. Similar to this, we have a while loop. While, let's say I'm defining a value A as 0, while A less than 5, print A, and then increment plus equals 1 actually means A equal to A plus 1. So this is one way to do it. That is a better or short way of doing it is A plus equal to 1 means this A equal to A plus 1. I'm just going to use this old syntax itself. Just all the confusion. Later we'll start using the other syntax later. So this loop actually loops and prints through A and increments the A value. Every time it loops, it will increment by 1. So 0, 1, 2, 3, 4, it will print. So this is how we loop through while loop. And next thing is defining functions. So for this, I think we should make use of this. I've already shown you this. If I am executing a print, hello, I'm actually calling a function called print. This is already predefined in Python. Print is a function, and hello is the argument to that function. So we are actually saying to the interpreter that you need to print this hello string out into the console. That's the function we are executing. So we can have our own custom functions defined in Python, which does its own operations. So I'm going to define a function. How to define a function is through def keyword multiplying by 3. I'm going to pass a value to it. I'm going to store it in a variable called val. Inside that function, I'm going to see this indentation. This is very important. If you don't indent code, it will throw error, or otherwise it will have logical errors in it. And I'm going to return 3 times that value that we are passing. I just defined a function now. I have not executed that function. When I did print hello, I've actually executed the function. Now, in order to execute this function, I need to call that function. Multiply by 3. I'm going to give a value of 4 to the value. It's going to return 3 into 4. 12. And similarly, I can define one more function, def multiply which this time it will accept two parameters, val1, val2. This is how we define a colon should be there at the end. And I'm going to return val1 to val2. And I'm going to multiply 3 and 4. So now let's do something with lists. Let's define a value variable A with list 1, 2, 3. We define a function that will append floor to it to accept a list, my list dot append of 4. And now I'm going to do append 4 to which list? To the list A. Now append A, it has manipulated this list object and added element 4 to it. And let's see. This is how we manipulate lists. Even dictionaries you can pass to functions that will in turn edit those dictionaries. So how about having return values? Now we have had a state function which returned return values. Let's say if I store value 3 equal to multiply of 3 comma 4, val 3 now contains the result of this operation. If I'm returning a value, this value can be stored in a variable again. Value 1 into value 2, 3 into 4 is going to be stored in val 3. If I print val 3, it's going to have value 12. Now what about print statement? Print hello if I do. Of the value it stores, let's say value 4, also print of hello. Now let's access val 4. Print val 4. It's actually a null. That means print statement is not returning anything. By default, any function that doesn't return anything will return none. None is a special type in Python. Let's see the type of none. This is called none type. If nothing exists, it is a none type. It's like similar to nil values in Java and C. So null spell. Let's try adding one value to none. Adding values to none is not allowed. This is about the basics of Python. So we will define classes tomorrow. So just a quick peek into classes. We define classes with class keyword. So classes are very useful for object-oriented programming, and an object is what we consider anything in the world, anything, an abstraction. Any object has its own attributes. All this attributes and methods, functionalities of a specific object, we will program into a template called a class. So that we will look. Let's say if you take an example of a dog, what it does, how many legs it has, all those things will be part of the class. So this is how I define a class. There are some attributes and methods in class. Just a quick peek I will do. We will discuss in depth into classes tomorrow. I'm going to initialize this dog. The syntax I will explain in some time. We will visit tomorrow. Example. how I created on. And this is an object. How to print this dog object in a human readable format and all that we will define. So, tomorrow. So how do we exit from this REPL? Is through Control C and enter. Or if I go here, do exit, exit, yeah, exit function. If I execute it,